How are you, my friends? This is another video of the series Math Common Errors. This is part 5, dealing with inequalities, table of signs, absolute value equations, and inequalities. Other videos on errors will be uploaded later. Let's start directly with the first one. We have one or two different from inequalities. The first one, if we have a function f of x is equal cube root of x cubed minus 8, somebody might ask, is this a straight line? Because some students, they think that cube root of x cubed minus 8 here can be simplified to x minus 2. And that's completely wrong, because we have a minus, or if we have even plus. So the correct function, this is a function not linear. This is the graph. It is not linear. This is cube root function. So that's a big mistake. Another mistake we can see in the equations. If we have x squared minus 5x is equal to 14, for example, that's an equation, and we can factor here x as a common factor is equal to 14, then we cannot continue solving this equation. On the other side, if we have this equation, you have to multiply and bring the 14 on the other side to make it 0. So this is completely wrong, and this one is the correct one. Factor it or use quadratic formula. You have to have 0 on the right side. Now, if you look at number 3 here, we see that this equation is quadratic in form. You can see algebra course lecture 24. If you need to find the solution, you know the method, let n is equal to 3 minus square root of x, etc. Factor it. If you try to find the sum of the solution, if you find 53, that's wrong, because one solution is rejected and the other is accepted. So only 49 is the correct solution. The idea here is you have to check, because you see we have here inside something square root, the index is even and you square both sides. So you have to check. That's the idea. Now, number 4, in the factoring and equations, if we have a minus b all squared, the same as b minus a all squared, that's the correct one. This is the mistake. If you take a minus outside, there is a squared, so it should be squared. If you leave the minus outside, that's wrong. Same thing, it happened in the absolute value. Absolute value of a minus b all squared, the same as b minus a in the absolute value all squared. Now, this one here, we have 5 common factor, but we cannot write here 5, because 5 is in the bracket with the squared becomes 5 squared, so 25. And then k minus 3 all squared. Same thing here, 10 minus 2. So there is a 2 common factor here. And then we have 5 minus x or x minus 5. The 2 will be squared, so that's 4 there. Okay, be careful. Now look here at this nice question. This is also quadratic in form. We have 2x minus 8, absolute value, all squared. And then we have the other thing here. See, many students, they take 2 common factor and they leave it 2 outside. This is the first common factor. Now the second one is 9, it's okay. There is no squared here, so 9 we can take out. Like here, I took 9. But when I take 2 from the first term, first common factor, it should be 2 squared, so that's 4. Just be careful, that's a big, 4 bigs mistake. And then the solution set will be 1 and 7. You can check it. Number 6, if we have inequality, just a normal inequality, divide or multiply by a negative number, you have to change the sign. So minus 6x less than or equal to 18. If you divide by minus 6, see? If you keep the sign, that's wrong. You have to change the sign of the inequality if you divide by negative number or multiply by a negative number. Number 7, if we have a polynomial inequality like x squared plus x less than or equal to 2, Big mistake. If you take a common factor here, x plus 1 less than 2, and then you take x less than or equal to 2, or x plus 1 less than or equal to 0, or whatever, everything is wrong there. The correct method, table of signs. Table of signs in algebra course lecture 25. You have to move all the terms to the left. Leave 0 on the right side. Then you know how to continue. Factoring, table of signs, the solution will be this one here. You can check it, please. Number 8. Another polynomial, but here we have x power 5 less than or equal to x cubed. Some people will divide by x cubed. You see here, if you divide by x cubed, it becomes easier. X squared less than or equal to 1. You see? Divide by x cubed, divide by x cubed. And then if you take the square root, x becomes less than or equal to plus or minus 1. This is a big mistake. This is a big mistake. Two big mistakes. Now, again, polynomial inequality. Degree 2, degree 3, degree 4, not linear. You have to move everything to one side, factor it, table of signs, and then you will get the answer there. You can check that. Number 9, another common error when we have 1 over x less than or equal 1 over x squared. Now you can cross multiply. Some people will do that. You see, 1 times x squared is equal 1 times x. It looks easy, then divide by x. So x less than or equal to 1. This is a big mistake. This is a big mistake. Two big mistakes here. This is a rational inequality. You have to move all the terms to the left, put 0 on the other side. You can move it to the right if you want. Put 0 on one side, all the terms on the other side. Make a table of sign as we do for polynomial. So you cannot cross multiply if you have denominator containing any variable. Now, this mistake here, number 10, we have, this one is a rational inequality. We know how to do it. You can move everything on one side, put 0 on the other side. But this error, not about the method of solving, but about the final answer. This is the final answer here. Minus infinity to minus 2 after you do table of sign, union 1 to 2. Why this one is a big mistake and this one is the correct? Because if you look at the denominator here, regardless of the equal, 2 minus x, x cannot be 2. 1 minus x, x cannot be 1. So we go to 1 and 2 and we make it open and we leave the other things closed except minus infinity and plus infinity. See the same numbers here, but if you put closed at 1 and 2 and they are in the denominator, that's wrong. So the idea here, always remove the zeros of the denominator from the final solution. Again here, we have 6 over x minus 4 less than or equal 5 over x plus 1. Many people say easy, cross multiply, 6 times x plus 1 times equal less than or equal 5 times x minus 4. If you solve this, you can get, this is a linear now, minus infinity to minus 26 closed. That's wrong. This is rational. You have to move it on one side, combine here all these fractions, and then you have to do table of signs again. This is the correct answer. Number 12. Number 12 is about how to do the table of sign and not to do other things. If you have like this rational inequality, we call this ready. Why ready? It's already factored. It's already on one side, 0 on the other side. Everything is ready. But this is wrong to write here, x plus 7. Many people will do it. X plus 7 greater than or equal to 0, x minus 4, whatever, greater or less, x plus 1. This is all wrong. You have to take the zeros, minus 7, 4, minus 1. Do table of signs. Check the algebra course, lecture 24. Let's move now to compound inequalities. This is compound linear inequalities where no need to split. In general, when we say compound, it means we have two inequalities. They can be less than or equal, anything. And then we have this compound. It can be linear like x power 1. It can be squared, quadratic, or cube, or any power, polynomial, or it can be rational, something over something like 1 minus 4x over 2x plus 1. Or we can have it absolute value. So if we have a linear like this, no need to split. We can just solve it. Please, you can try yourself. Do some steps here. See the algebra course, lecture 24. See here, you subtract 1, subtract 1, subtract 1. Then you divide by minus 4. Remember, minus, we change the sign, both signs. And then you get the answer in the solution here, minus 7 over 2 to 6 closed. Now, we will look at math common errors number 13. 16 less than or equal x squared less than 25. This is closed, this is open. That's not the issue. Now here we have polynomial, see, or quadratic. Not only x. If you have x, that's linear. Now you cannot take the square root like this here. Square root of this, square root of this, square root of plus or minus. We don't have plus or minus in the inequalities. The other way you can do this one, you can split it. See, two table of signs. 16 less than or equal x squared. You have to make intersection with x squared less than 25. You do this separate table of signs. Move the 16 here greater than 0. Move the 25 here, factor it, less than 0. This is the solution. This is not the solution. That's wrong. This is the solution. Open minus 5, closed minus 4, union, closed 4 to open 5. Now, another method can be shown here. You see, x squared between 16 and 25. See this one here we split it. But this one, I can take the square root because all of these are positive. But remember, this is only 4, the square root of 16, only 4, this is only 5. And when you take the square root of x squared, because the index is even, we put absolute value. Then you have to split it now. See, 4 less than or equal absolute value of x, and then you make intersection with absolute value of x less than 5. You have to split it now. You will get the same answer, but here you have to use the cases in the absolute value, case 2, case 3. All right, now we have minus 2 less than 1 over x less than or equal to 3. See, that's compound too, and also rational. Now, some people will do this one here. Take the reciprocal, 1 over x, make it x, 3, 1 over 3, minus 2, make it minus half. That's the solution, that's wrong. Or you can change the signs also and make the reciprocal. That's also wrong. What is the error here? Taking reciprocal because we have a minus. See, if all are plus, 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 all positive, we can take the reciprocal. Now, the only way we can do this, minus 2 less than 1 over x, you see, split it, intersection, the other one, 1 over x less than or equal to 3. You need table of sign, you bring everything on one side. Here you bring everything on one side. Make it another table, find the intersection. That's the answer. Minus infinity to minus half. Open, union, closed, 1/3 to infinity. Now we come to absolute value inequality here. Absolute value x minus 1 less than or equal to 5. I have seen students, when they apply the rule here, we have to apply case number 2. Case number 2, case number 3, this is in algebra course, lecture 26. They put absolute value x minus 1 between minus 5 and 5. That's wrong. See, when you apply the case 2 or case 3, you have to remove. That's the idea of case 2 and 3. Remove the absolute value. So x minus 1 between minus 5 and 5. Then you continue, the answer is there. So remember, he must remove the absolute value bars when applying case 2 or case 3. Now, another mistake we can see in case number 2. Suppose we have 5x minus 2 less than or equal to 6. Some people, they will take 5x minus 2 greater than minus 6 or less than 6. That's wrong. Or they take less than minus 6 or less than 6. That's also wrong. The correct way is for case 2 is take the expression inside between, remember this word, between minus 6 and 6. In one compound, there is no need for or. Please listen. No need for or if we have case 2. In case 3, yes, we need. Now, let's come back here. This is a linear, you see? If you have a squared on the x or cube, then you have to split it as we did before. Split if not linear. Not linear, split it. Linear, just add 2, add 2, add 2, and then divide. This is the solution here. Now, another mistake we can see here, look here. Absolute value of x squared minus 3 less than or equal to 6. If you take this as greater than minus 6, or we mentioned that before in number 17, that's wrong. The correct apply case number 2. Then you split. Don't split before. So you apply case number 2. The whole expression x squared minus 3 between minus 6 and 6. You must split now. So you take this one, intersection the other one, then the final solution is there. So apply case number 2, then split, if not linear. This is polynomial or quadratic or cubic or rational or absolute value. You have to split all except only linear. This is error number 19, compound absolute value inequality. If we have a nice question, actually, 1 less than or equal to absolute value 10 minus x minus 3 less than 9. Some people, they do like this. They split it, 1 less than or equal to absolute value 10 minus x minus 3. Intersection, the other side, absolute value 10 minus x minus 3 less than 9. The idea of splitting is okay, but you're applying that in the wrong manner because we have a minus 3 there. So you have to add 3, add 3, add 3. Rearrange, we call this. Rearrange it so it will be 4 less than or equal to absolute value 10 minus x less than 12. Now you split it. Then you apply case 2, case 3 of the algebra course, lecture 24. So again, you add 3 to each side until you have it ready. Absolute value between two inequalities. Then you split it and then apply case 2, case 3, check the lecture 24, then you find the solution there. Find the solution. Now, absolute value inequality, we have absolute value greater than 3 here. Since we have a greater with the absolute value, you cannot write x minus 7 greater than 3 less than or equal to minus 3. That's wrong. It has no meaning. Or x minus 7 greater than or equal plus or minus 3. That's also wrong. The correct way is absolute value greater, apply case 3 in the algebra course, lecture 24. So x minus 7 less than or equal to minus 3, or x minus 7 greater than or equal to 3. This is the final solution here. Remember, applying case 3 without writing or, that's the mistake here. You have to split it already from the formula, case number 3. So you must write or when you apply case number 3. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you very much.